Following on from the previous video, we should be using the limit comparison test. So with the limit comparison test, you're trying to investigate your series. You're trying to investigate something that you know nothing about, and then compare it to something that you do know about. Well, this thing here, in the previous video, we said that as n heads towards infinity, this thing here will act as this thing here. Well, this thing here, well, you can rewrite it as 2 over n squared. Well, and when you take the summation, the 2 comes out here, so it's like this, summation 1 over n squared. Well, this thing here we know is going to converge. When you times 2, the whole thing will converge. So with the limit comparison test, you're trying to investigate something that you know nothing about. You're trying to investigate something that you know nothing about, and then compare it with something that you do know about, and then compare it with something that you do know about. This thing we do know that it's going to converge. So with a limit comparison test, you got to make sure that it's an is always bigger than 0. So this is our an here. So from 2 to infinity, this will always be positive, this will always be positive, meaning the whole thing will always be positive. So this bit here has been satisfied. And then check your Bn. Well, Bn is this thing here, because we are trying to investigate this, which we know nothing about. We compare it with something that we do know about. This thing we do know that it will converge. So your Bn here, this is your Bn. So this is your Bn. As n moves from 2 to infinity, this will always be positive, this will always be positive, making the whole thing always positive. So this thing here has been satisfied. So with the limit comparison test, we always need to compute this value here. An divided by Bn. Well, this is our An, this is our Bn. So An divided by Bn is this thing here. So An divided by Bn, that's the same as multiplying the reciprocal of Bn, which is this thing here. Well, this thing here then becomes this, okay? And then as n heads towards infinity, this is going to be n to the power 3 over n to the power 3, which will be 1. So we've just computed this value here. We've just computed this value here. Well, this value here is 1. Well, 1 here is bigger than 0. So we should be looking at, hang on. So we just computed this value here, and this value turns out to be 1. Well, this 1 here is bigger than 0, so we should be looking at this scenario here, because we've just computed this value. This value here equals 1. Well, we've just computed this value here. This value here does not equal 0, so we can forget about this. We've just computed this value here, which equals 1, and 1 is not infinity, so we can forget about this. So we should be looking at this scenario. Okay, looking at this scenario is saying that the thing that you're trying to investigate, compare that with something that you know about. The thing that you're trying to investigate, compare it with something that you know about. Well, if it's greater than 0, then they both converge, or they both diverge. Well, here this thing we know that is going to converge. Therefore, the thing that we know nothing about will also converge. So this thing here will converge. Okay, just because this thing here converge, therefore this thing must converge, because it's saying they both have to converge or they both have to diverge. Well, this thing here converge, therefore this thing converge. Okay.